Hi, Math11. I've been getting lots of questions from the stuff that we've been working on. So what I'll do tonight is I'll go over the answers to some of the questions that you guys gave me, and then I'll just give you some review work on the stuff that we've covered so far with this chapter before I go to the last topic. I'll cover the last topic on Tuesday. Okay, so I'll give you some time to kind of just work on the stuff we've been covering. Okay, so here's a question I got. It gave you the graph. This was the question. So it gave you the graph as is here. So it's a parabola. And it asked you to convert this graph to an absolute value. Okay, so again, what you have to recognize from an absolute value function is that the equation down here is invalid. Okay, and so what happens is this part right here is going to have to get reflected. Okay, and so it can't exist here. These parts here are fine because they're in the positive. So when we say a reflection, what that means is this side's going to basically look like that. Okay, so it's going to be like this. So this will be your absolute value function. Okay, so that's why you end up getting this sort of W-shaped function. Okay, another one I got was this one here. So what you want to do, the y-intercept you can get right off the bat. You just make x equal to 0, so that's 0, that's 0, so you just get 6 as a y-intercept. And then the x-intercept, what you're going to have to do is you're going to have to factor that, because you have to set y equal to 0. And so when you factor that, you get negative 2 and minus 3, okay, as the two solutions. So again, it's going to be similar to this one here. Your negative 2 and your negative 3 are right here. Okay, so there's negative 2, negative 3, negative 2, and there's 6 for your y-intercept. Okay, and so again, this is a positive parabola because your x squared isn't negative, so you know it's going to open up. So we can open up this way here, we can open up this way here. The bottom is actually down here somewhere, but again, that can't exist. Okay, so just like this one here. So you have to loop that at the top there. Okay, if I want to be more precise and know exactly where the vertex is, like down here, which would be the opposite up here, then I can convert this into vertex form by completing the square. Okay, if I wanted to, but I think the question was just basically asking for a rough sketch. Okay, number 9 here. So they gave you the graph again. Okay, so the graph was given into the question, and they told you what the function was, and they basically want you to explain what the piecewise is. Okay, and then when you do the piecewise, you have to include the inequality. So that I was getting a few questions on that, how to do the piecewise, and also how to figure out the inequality. Okay, so when you do the piecewise, you basically set this up so that there's two forms to this, right? So one is just the way this is written, and the second is the negative of it, the reflection of it, which is you take the same thing and you put a negative in front of the whole thing, and so that'll give you these two. Okay, so this is the way it's written as is up here. And then here's the negative. Okay, so when you do the negative, make sure you put brackets around this, so the negative is being applied to everything inside the brackets. So the positive is this one here. Okay, and so there's one. This is called an invariant point because it exists for both sides. So there's one, and so what we're saying is this part of it is valid so long as x is greater than and equal to 1, because if it's the other side less than 1, then it actually goes down. It actually goes down here, right? Which is not valid. And then the negative part is this part here, which exists when x is less than 1. So in terms of, like, once you figure out the first one, the second one is just going to be the opposite. Okay, so you should be seeing that pattern for all of these. Okay, 10C is the same thing. They give you this graph. Okay, so the graph is provided to you. They tell you what the function is, and same idea. They want you to give the piecewise. Okay, so this is This is an absolute value where you're looking with linear, two linear lines, right? So they're straight lines. And this is one where you're looking at a parabola. Again, the reason why you get this weird shape is because the parabola is actually starting down here, right? But this part here doesn't exist, so it gets reflected up here. So same thing we did over here. You write one the way it is already, and one that's negative. Okay, so here's the one that's written the way it is already. Here's the negative. Again, the negative is working off of everything. And then what I've got here is you've got 2 points, 1 and 3. So with the function written as is up here, it's valid so long as your 1 are to the left and so long as your 3 are to the right. So that's why we're saying x is greater than or equal to 3 or less than or equal to 1. Okay, this middle part here is what's describing the negative, the reflection. Okay, so that's what this minus is doing. It's reflecting it. And that is saying you have to be between 1 and 3. So again, the inequality is the same values, but the inequalities are opening up in the opposite direction. Okay, the next page here. So now we're starting to get into the calculating, and this is what we looked at last class. So this is the absolute value part. So this part here isn't in the absolute value. So when we do the piecewise, we just care about the absolute value part. And so again, there's two versions. There's one that is as is, and there's one that's a reflection with a negative in front. And so here, the way it's written as is, you have to be equal to or greater than 0, right? So meaning you have to be positive. So x. So if you're trying to figure out what is that going to be, you can go 7 plus 3x equals 0, 3x equals negative 7, and so x equals negative 7 over 3. Okay. And so what we're saying here is x has to be greater than or less than, greater than or equal to negative 7 over 3. So it can't be less than that. And then the reflection is, again, the opposite sign. So this part's really important. You need to do this part, and then you need to figure out what these are, because this will help when you're trying to figure out extraneous solutions. Okay, so now what you do is you solve both of these. Okay, and so here's the first one. Okay, so 7 plus 3x, and now we can include the second part here, 11 minus x, and then you solve for that, x equals 1. Okay, so you look at this, is 1 greater than or equal to negative 7 over 3? It is, so that works. Okay, and then we do the negative 1. Okay, so here's the negative 1. Again, 11 minus x, that's the non-absolute value part. You solve for that, you get negative 9. Is that less than negative 7 over 3? It is, so that's your solution. Okay, so again, this resembles the absolute values that look like that. Okay, so that's resembling those ones. Now the parabola version is what you get here for 6a. Okay, so same thing. Now this one you have to figure out, again, we just care about the absolute value part. So there's two possibilities. It stays the way it is, or it's a negative version. So if it stays the way it is, x has to be greater than or equal to 0. If it's negative, then it has to be less than 0. So again, these are always opposite. So solve both of those. Okay, so this is the first one. We just let that x, so there's x here and x here, they cancel out. You get x squared minus 3 equals 0. X squared equals 3, so x equals plus or minus root of 3, but we only want the one that's greater than or equal to 0. So that's why we only got the positive one. Okay, so the negative root 3 is not valid, even though it is a solution here. It's not valid because it doesn't meet this criteria. Okay, and then we do the negative version. Okay, so it's right here, and now we collect it, and then we can factor it. So you get x minus 1 and x plus 3. So you get two answers, 1 and negative 3, but 1 is not less than 0. Okay, so this one is not an answer. Okay, so that's extraneous. So your solution is root 3 and negative 3. Okay, so those are your two answers. Okay, so again, you gotta, when you get your answers, you gotta test it against these inequalities. Okay, um, and then here's another one, x squared minus 1. So same thing. So now this time I need to find out what the zeros are. So what I can do with the absolute value part, because this is a difference of squares, I can factor that, x minus 1, x plus 1. And so now I've got 1 and negative 1. And so there's 1 and negative 1. Now you might be confused as to figure out, like, how do I know it's greater than or less than? So when we get into that type of situation, you can use a test value, right? So let's say x is 2. 2 squared is 4. 4 minus 1 is 3. That's greater than 0. Okay? Less than negative 1. So if I had negative 2, that'd be squared to be positive 4. So that would work. If I had the other way, if I had like 0, 0 minus 1 is negative 1. That wouldn't work. Okay? So you can use test values to figure out which way these are supposed to go. And then here's your negative. Okay? And so again, the directions are opposite. Okay, and so now this is done the same way. Here's looking at the one that's written as is, x squared minus 1 equals x. We can't factor that, so we'll use the quadratic equation. And now that gives us two answers, plus and minus. The minus isn't going to meet the criteria over here. Okay, so that's why we only have the plus one as an answer. And then we do the second one, which is a negative. And then remember that negative is applied to everything. And you put that in. And again, you get plus or minus. But the minus isn't applicable here. So you get this one. Okay, so those are your two answers. So I can go over more questions if you have more that you'd like me to go over. So again, I'm not going to give you any new stuff. The new notes tonight. I'll give that to you on Tuesday's class. So this is these are review questions. I was going to give these to you at the end of the chapter, but these are the review questions that only cover the first three sections which we've done. Okay, so I think it's useful if we don't cover new stuff tonight. You go through the review questions, and then let me know which one of these that you have a problem with, and I can begin next class by going over these questions. And then so Tuesday I can go over any of these questions first, and then I'll go over the remainder of the notes and give you some additional questions. So that'll be Tuesday's class. And then Thursday's class I'll give you just Thursday's class, then I'll give you the take-home exam. Okay, so Thursday I'll give you the take-home exam. Now, some of you are asking about the last take-home exam. I'll mark that one over this weekend. Okay, so again, if you still haven't handed that in, please do so, and I'll hand it. I'll let you know your results over the weekend. Okay, so again, stay safe. Keep asking the questions. That's really good. And like I said, next week I'll give you the take-home exam. Okay, bye for now.